In this video, we're going to talk about the rational zeros theorem. This is a really cool and helpful theorem for factoring a polynomial that, when you look at it first, you're like, oh, I have no idea how to factor this. Rational zeros theorem can really come in handy in those situations. So what it says is that if you have a polynomial and it has only integer coefficients, that's kind of important. And then if it also the last coefficient and the first coefficient need to not be 0, then p divided by q is a 0 of f of x. So it's going to tell you what a 0 of f of x is. But what it tells you is that p is a factor of the last coefficient and q is a factor of the first coefficient. So let's go ahead and let's do an example. So say we had to find all the zeros of f. We can start by finding all of the rational zeros of f using the rational zeros theorem. So to get started with that, we're going to have to find all the factors of the first and last term, and then find, we're going to have to divide all of those factors with each other, and then say, okay, so those are the possible zeros of f. Okay, so let's go ahead and start this process. So let's say factors of -4. Let's start with the last term, or last coefficient. So factors of -4, what are they? Well, both positive and -1 are divisible by -4. And then also positive and -2. And then also positive and -4 are all factors of -4. And then let's talk about factors of the first coefficient, factors of 2. So plus or minus 1 and plus or minus 2. Okay, so possible zeros. Let's make a list of possible rational zeros. Okay, and it's kind of a key thing here that we're only finding the rational zeros. This theorem isn't going to find us a 0 where it's like, the square root of 2 or something. If that was a 0, it's not going to find that answer. Okay, so only rational numbers. So possible rational zeros then, so what I'm doing is I'm going to take these numbers and divide them by all the combinations of these numbers. So all these numbers divided by 1 are just going to be themselves again. So that's going to be plus or minus 1, plus or minus 2, plus or minus 4. And then let's divide all of the factors of -4 by plus or minus 2. So that would be plus or minus 1/2. 2 divided by 2 is 1, which has already been listed here, so I don't need to do that twice. And then 4 divided by 2 is 2, which is already listed, so I don't need to list that again. Okay, so these are all the possible factors of this f of x. Now, I have two options to determine which of them are actually zeros. First option is I can plug them back in for x. I can plug all of these numbers in for x, and find when f of x equals 0, right? The other option is I could use synthetic division and find when the remainder is 0. I like using synthetic division because then it gives you the other part of the factor. So let's go ahead and do that. We'll use synthetic division to try to test which of these are zeros. Okay, so let's get started with using synthetic division. First thing, let's make sure our powers are, I think I wrote that wrong. There should be an X there. So make sure that the powers are good. So we have 4, 3, 2, 1. All right, and then 0. So the powers of this is looking good. So let's go ahead and grab all those coefficients. So we'll have 2, 3, 8, 3, -4. And so let's get started. Which 0 do we want to try first? We can try maybe positive 1. So I'm just starting on the left, moving right. Try them all. We could try them all until we find one. So let's go ahead and do this really fast. This is 1. 1 times 1 is, that's 2. Drop down the 2. 2 times 1 is 2, 5, 5, 13, 13, 16, 16, 12. Okay, that's not a 0 because if if 1 were a 0, then this remainder would be 0, and it's not, so this one didn't work. Let's try -1. Okay, sometimes this can be time consuming. You have to just go through and find all of these. Test all of these perhaps. So -1 times 2 is -2, 1, -1, 7, -7, let's see, 4, -4, and then +4 and 0. Oh, this one has a remainder of 0. Great. So x equals -1. That's a 0, right? So it's a 0, meaning it is a, if you plugged it in, you would get 0 for f of x. Okay? So if I were to now try to factor f of x, it would be x plus 1, right? And that's where I'm getting this from. And then here, this is, what do I have here? I have, this would be x to the third, x squared, this would be x. Okay, so I'd have 2x to the third plus x squared plus 7x minus 4, right? And I got that from my synthetic division solution. Okay, so now I can see if I can maybe, use the rational zeros theorem again to find any zeros of this polynomial, and then continue to factor, because at this point I found 1 0, but it looks like this is still maybe factorable, so I should do that. So first, let's look at our first and last coefficient, and let's find a group of possible zeros. So factors of -4 and factors of 2. So factors of -4, plus or minus 1, plus or minus 2, plus or minus 4. These are, I guess these are the same, plus or minus 2. So our possible rational zeros for this polynomial here are the same, actually, as the other polynomial. So it would be plus or minus 1, plus or minus 2, plus or minus 4, and then plus or minus 1/2. Okay, and the way I got that is the same way. So you just do, so 1 divided by all of these, and then 2 divided by all these. So you have the 1/2. This is 1, which was already included, and then this is 2, which was already included, so you don't list it twice. So let's go ahead and go to the next slide to find some zeros of this. Okay, so again, we're going to use synthetic division to test what is a possible zero, or which of the possible zeros is an actual zero. So remember, the possible zeros were plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 1/2. So you can pick any number to try first. You can go through the whole list. I'm going to go ahead and choose -1 to start with, or -1/2 actually. I'm going to choose -1/2 to start with. So let's go ahead and list our coefficients. So we have 2, 1, 7, and -4. Okay, so let's see, I have dropped the 2, so I'll have 2, and the -1/2 would be -1, 0, 0, 7, -7/2, which doesn't add up to 0, so this is not a real zero, or rational zero. So let's try positive 1/2. 2, 1, 7, -4. So drop the 2. 2 times 1/2 is 1. 1 plus 1 is 2. 2 times 1/2 is 1. 8. 1/2 times 8 is 4. 0. Okay, so there it is. There's the rational zero. So, so far we found that x equals 1 is a 0, and now we just found x equals 1/2 is another 0. So let's go ahead and rewrite f of x. So it's x plus 1, x plus 1/2, and now we have this left over, so we have this here. So that would be x squared, and then this is an x. Okay, so that'd be 2x squared plus 2x plus 8. Okay, so now once I get here, I look and I see I have what kind of, what looks like a quadratic equation, and then I know how to solve. If I were to put this equal to 0, I know how to solve this using quadratic formula or something. So at this point, I probably would just go ahead and do that. So let's rewrite this. I can pull out a 2 from that, so I should go ahead and do that. So let's go ahead and pull out a 2. So then I'll have x squared plus x plus 4. Alright, I'm going to look at that for a second. Is it factorable? Is it easily factorable? If so, then go ahead and do that. Otherwise, yeah, let's maybe we can use completing the square method or the quadratic formula to solve when this equals 0. So let's go ahead and let's do that on the next page. Okay, so here I've just rewritten what we've now factored f of x to be, and well, we've already found that. Let me go ahead and write this. So if we're trying to find the zeros, so x equals -1, that's 1 0. X equals 1/2, that's another 0. So this is one answer, this is another. And then now we need to know what 0 is this over here. So, or zeros. So we need to solve this. X squared plus x plus 4 equals 0. So to do that, I'm going to use the quadratic formula. Okay, so use the quadratic formula. Okay, so what is the quadratic formula? X equals plus or minus b, x equals minus b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so b is 1, a is 1, and c is 4. Okay, so -1 plus or minus the square root of 1 minus 4 times a, which is 1, c, which is 4, divided by 2 times a, which is 1. Okay, so this is -1 plus or minus the square root of 1. 4 times 4 is 16, divided by 2. So this is -1 plus or minus the square root of -15 over 2. Okay, now we have the square root of a negative number, which is not a real number. Okay, so these are the only real zeros of f of x. This will be a non-real number. So, there's no real solution to this quadratic formula. So no solution. So your only two zeros are x equals -1 and x equals 1/2.